Why? The leader of NASA recently disclosed that something extraordinary has been uncovered by the James Webb Space Telescope, our most sophisticated instrument for exploring the universe. Prepare yourself for an exciting announcement coming from the farthest reaches of our galaxy, the discovery of life on Proxima B's planet. This revelation could alter everything we know. Come along with us as we look into the mysteries that the Webb telescope has revealed and the possible effects that the discovery of life on Proxima b could have on humanity and space exploration in the future. The James Webb Space Telescope, a feat of modern science, has the potential to completely transform our comprehension of the universe. With its state-of-the-art technology and optimal position in space, it allows researchers to observe distant stars, galaxies, and planets in ways previously unimaginable, offering an unparalleled view of the cosmos. Although this might seem like an exaggeration, the technology behind the telescope fulfills its promises. One of the most remarkable aspects of the Webb telescope is its 6.5-meter primary mirror, which is more than twice the size of the Hubble Space Telescope's primary mirror, a pivotal tool in space exploration for over 3 decades. The Webb's large mirror enables it to capture even the faintest glimmers of light from the farthest reaches of space, including areas once too remote for other telescopes to observe. In the past, scientists could only hypothesize about what might be observable with conventional telescopes. Now, with the Webb telescope, they can witness those distant cosmic phenomena in exquisite detail. Along with its expansive mirror, the Webb is equipped with a range of cutting-edge instruments capable of detecting a wide array of light wavelengths. One such device, the Near-Infrared Camera, NIRCam, is designed to capture images in the near-infrared portion of the electromagnetic spectrum. This is essential because infrared light can penetrate dust clouds that typically obscure visible light, enabling researchers to peer deeper into space. With its high resolution, NIRCam allows astronomers to closely observe star formation in galaxies. The aim of these observations is to examine the early universe, its initial light, the origin and progression of galaxies, and to identify and investigate exoplanets that were once unreachable by other telescopes. The Webb's advanced instruments, such as NIRCam, reveal intricate details about the universe's structure, shedding light on how galaxies assemble and evolve over time and helping us understand the forces that shape the cosmos. The Near-Infrared Spectrograph, NIR-SPEC, is yet another essential instrument on board the Webb telescope. This device plays a key role by breaking down light from distant astronomical objects into its individual wavelengths. This process, known as spectroscopy, offers vital information about the temperature, velocity, and chemical composition of these objects. NIR-SPEC enables researchers to explore stars and galaxies in greater depth using the absorption and emission lines in their spectra to identify the chemical elements present and understand the interactions between celestial bodies. It also aids in studying the life cycle of stars and galaxies, offering insights into their formation, evolution, and eventual demise. One of the Webb's primary missions is studying remote galaxies whose light has traveled billions of years to reach us. Astronomers are able to unravel the mysteries of their evolution by analyzing the spectral data from these galaxies and determining their age, chemical composition, and other characteristics. The Mid-Infrared Instrument, MIRI, is another critical tool that allows the study of longer wavelengths of infrared light, which helps in examining objects like stars, planetary systems, and dusty regions where new stars are being born. MIRI also enables astronomers to explore the atmospheres of exoplanets, providing crucial information about their composition, temperature, and potential for supporting life. Particularly captivating are the regions of space where stars are born. While blocking visible light, these dense clouds of gas and dust allow infrared radiation to pass through. Thanks to MIRI, scientists can observe the formation of stars and planetary systems, studying the physical processes that occur within these cosmic nurseries. MIRI is also indispensable in identifying exoplanets, as it can detect and analyze the faint infrared emissions from their atmospheres, revealing essential details about their environment, including the presence of water vapor, carbon dioxide, and other compounds that could sustain life. The Webb telescope mostly uses spectroscopy and atmospheric analysis to look for signs of biological activity on exoplanets. Even if a planet lacks visible signs of plant life or oxygen, these elements are not always necessary for detecting life. Spectroscopy, which examines how light is absorbed or emitted by an object, plays a central role in analyzing the atmospheres of exoplanets. The Webb can observe the light passing through the atmosphere of an exoplanet when it transits in front of its parent star, a phenomenon known as a transit event. This interaction leaves behind subtle chemical signatures that can be analyzed to identify molecules in the atmosphere. The Webb uses two primary instruments for this task: MIRI, which concentrates on the mid-infrared spectrum, and NIR-SPEC, which focuses on the near-infrared spectrum. Together, these tools cover a broad range of wavelengths necessary for a comprehensive examination. During a transit, the light passing through an exoplanet's atmosphere carries information about the planet's chemical composition. The Webb analyzes these signals to determine the makeup of the atmosphere, identifying molecules that could indicate the presence of life or conditions that might support it. By identifying distinctive spectral signatures, scientists can construct models to better understand the planet's atmosphere and climate. One of the key objectives of the Webb's mission is to search for biomarkers, compounds that are associated with life, such as oxygen, methane, and water vapor. However, recognizing these compounds is just the initial step. More observations are required to evaluate the planet's habitability and any signs of biological processes. Another valuable tool is comparative indicator spectroscopy, which the Webb utilizes to enhance its search for life. By comparing spectral data from different planets, researchers can make meaningful conclusions about the potential for life beyond Earth. The James Webb Space Telescope's ability to detect biological markers in the atmospheres of exoplanets signifies a revolutionary step forward in the quest for extraterrestrial life. This telescope's unique combination of technological features allows it to observe distant planets with a level of precision that was once unachievable. New insights into the possibility of life on other planets are emerging as scientists continue to investigate the data gathered from these observations. The Webb telescope's capacity to peer into the far reaches of space lets us look back in time and observe the earliest stages of the universe. The Webb provides a unique opportunity to study the evolution of the universe by capturing light from galaxies that formed billions of years ago. These observations shed light on the intricate processes that gave rise to the stars, planets, and galaxies we know today, as well as their formation. In addition to its search for life, the James Webb Space Telescope is playing an essential role in advancing our understanding of space in general. Scientists are using its capacity to take precise images of distant galaxies, stars, and other cosmic phenomena to reconstruct the universe's past. With every new discovery, the telescope continues to challenge our assumptions about the cosmos and expand the implications for space exploration, deepening our understanding of the possibilities that exist beyond our planet. Looking ahead to the future, the Webb telescope will remain a vital tool in exploring the unknown. Its findings over the next few years may have profound repercussions not only for our comprehension of the universe but also for the development of space exploration in the years to come. The James Webb Space Telescope will undoubtedly be at the forefront of this exciting journey as we venture further into space and continue our search for life-signaling objects. To conclude, the James Webb Space Telescope represents the dawn of a new era in space exploration. A significant milestone in our quest to comprehend the universe is its capacity to spot exoplanets, distant galaxies, and signs of life. With its powerful instruments and unmatched capabilities, the Webb is set to revolutionize the way we study space and unlock the secrets of the cosmos. The James Webb Space Telescope's ability to investigate the atmospheres of exoplanets is perhaps one of its most thrilling functions, as it enables scientists to search for subtle signs of life in distant worlds. This telescope's advanced tools allow us to observe planets and their atmospheres with an unprecedented level of clarity. The web is a useful tool for determining if other planets might support life by identifying essential compounds like oxygen, methane, and water vapor that could indicate its presence. These capabilities extend beyond simple observations. The web's advanced technology assists us in making important comparisons with Earth, enabling researchers to assess how planets with similar characteristics could potentially sustain life. Through detailed spectroscopy, the telescope can break down the light from distant stars and planets, giving scientists a snapshot of the chemical composition of these worlds. This process is crucial for determining whether exoplanets may have environments that could support life, and it opens up new avenues of research into the nature of habitable zones within the universe. Because it can focus on the infrared spectrum, the web can also see things that were previously hidden, like how stars form in dust clouds or how planets form. Traditional telescopes that use visible light are often unable to see these regions where stars and planets are formed. However, the web's infrared abilities allow it to peer through this cosmic dust and reveal details that would otherwise remain concealed. These observations offer